In this video, we're going to go over some molality practice problems. We're going to focus on how to calculate molality of a solution given grams, milliliters, or if we're given molarity, density, or mass percent, and vice versa. So these are some formulas that you need to know. Molarity of a solution is equal to the moles of solute divided by liters of solution. Molality is another form of concentration, and it equals the moles of solute divided by the kilograms of solvent. And the mass percent is the mass of the solute divided by the total mass. And another formula that you need to be aware of, which will be useful in this section, is the density of a solution. It's equal to the mass of the solution divided by the volume. So you need to know that as well. And so what we're going to do is we're going to go over a few problems, and so you can put this information in practice. So let's go ahead and begin. So here's the first one. 32.5 grams of sodium fluoride is dissolved in 425 grams of water. Calculate the molality of the solution. So molality is moles of solute divided by kilograms of solvent. The solute is the sodium fluoride. The solvent is the water. Sodium fluoride is dissolved in water. So we need to convert the grams of sodium fluoride into moles. So first we need the molar mass of sodium fluoride. And we can get that information from the periodic table. The molar mass of Na is about 22.99, so we're going to say 23. And for fluorine is 19. So the molar mass is 42 grams per 1 mole. So let's start with 32.5 grams of sodium fluoride. And let's convert that into moles. So 1 mole of sodium fluoride has a mass of 42 grams. So notice that the units grams of NaF cancel. Now the next thing we need to do is we need to divide by the kilograms of solvent. Right now we have moles. Moles over kilograms is going to give us the molality. Now notice that we have 425 grams of water. To convert that to kilograms, we simply need to divide by 1,000. 1 kilogram is equal to 1,000 grams. So the units grams cancel. So 425 divided by 1,000 is 0.425 kilograms. So this is going to be 1 over 0.425 kilograms. So notice that we have moles of solute on top, kilograms of solvent on the bottom. And that's kilograms of water. Moles of a kilograms is basically equal to the molality. So now, at this point, let's go ahead and calculate the molality of the solution. So 32.5 divided by 42, that's 0.7738 moles, and then take that divided by 0.425, and you'll see that the molality is about 1.82. Lowercase m is for molality. So that's how you can calculate it. Number 2, 32 grams of sodium hydroxide is dissolved in enough water to make a 325 milliliter solution. Calculate the molarity of the solution. So we know molarity is defined as the moles of solute divided by the liters of solution. So we need to convert grams of sodium hydroxide, which is the solute, into moles. So let's find the molar mass first. Sodium has a molar mass of 23 according to the periodic table, and for oxygen it's 16. For hydrogen it's about 1. So sodium hydroxide has a molar mass of 40 grams per mole. So if we start with 32 grams of NaOH, we can convert it to moles by dividing by 40. So 1 mole has a mass of 40 grams. So notice that the units grams of sodium hydroxide cancel. Now we need to convert milliliters into liters of solution. And it turns out that 1 liter is equal to 1,000 milliliters. So by dividing 325 by 1,000, we can get the liters, which is 0.325. So if we divide the moles by liters, we can get the molarity of the solution. So 32 divided by 40 is about 0.8 moles. And then if you divide that by 0.325 liters, you'll have the molarity, which is 2.46. Capital M stands for molarity. Lowercase m is usually associated with molality. Number 3, 74.5 grams of calcium chloride is dissolved in 560 grams of water. The density of the solution is 1.15 grams per milliliter. Calculate the molarity of the solution. To find the molarity, we need the moles of solute, which we can get by using the grams of calcium chloride, and we need to divide that by the liters of solution. We don't have the milliliters, so we got to find it. So let's focus on the solution part. Now, we have the mass of the solute, which is calcium chloride, and we have the mass of the solvent, which is water. The solute plus the solvent is equal to the solution. The solute and the solvent combined makes up the solution. So, if we have 74.5 grams of solute and 560 grams of the solvent, we therefore have, if we add these two numbers, 634.5 grams of solution. So we can use that and we can convert it to milliliters using the density. So let's do that. 634.5 grams of solution over 1, and the density is equal to 1.15 grams per milliliter. That means that there are 1 milliliter of solution for every 1.15 grams of solution. So notice that the units grams of solution cancel. And we need to take it to one step further. Let's convert milliliters into liters. Now, for every 1,000 milliliters, there's 1 liter of solution. So 634.5 divided by 1.15, that's about 551.7. And then if you take that and divide it by 1,000, you can get the number of liters, which is 0.5517 liters. So now, let's calculate the molar mass of calcium chloride. So, calcium has a molar mass of 40.08 according to the periodic table, and for chlorine, there's 2 of them, so it's going to be like 35.45 times 2. So 35.45 times 2, that's like 70.9. If you add 40.08 to that, you should get 110.98. So now we have everything we need to find the molarity. So starting with 74.5 grams of solute, which is calcium chloride, we can convert that to moles using the molar mass. So 1 mole of calcium chloride has a mass of 110.98 grams. So the units grams cancel. And then, now that we have the moles, to find the molarity, we need to divide by the liters of solution. So moles over liters is molarity. So 74.5 divided by 110.98, that's 0.671 moles, and take that divided by 0.5517, and now you have the molarity, which is about 1.22 capital M. Four, calculate the molality of a 0.425 molar aqueous solution of potassium hydroxide having a density of 1.13 grams per milliliter. So in order to find the molality, we need to get the moles of solute and divide it by the kilograms of solvent. So we got to break this problem into different parts to find the grams of solvent in order to get the kilograms of solvent. So let's start with the molality. The molarity. Molarity is moles over liters. So a 0.425 molar solution means that there are 0.425 moles of solute, or moles of KOH, for every 1 liter of solution. So we're going to say that there are 0.425 moles of KOH. And if we make that statement, then we can say that there's a 1 liter of solution. And we can get the answer right by making that assumption, because that's going to equate to a molarity of 0.425 m. So since we have the moles of KOH, we can find the grams of KOH. So let's go ahead and do that. So 0.25 moles of KOH times, we need to get the molar mass. The molar mass of K is about 39.1. And for oxygen, it's 16. And for hydrogen, it's about 1.008. Or you could just say 1. So the molar mass for KOH is about 56.108 grams. So moles cancel. So 56.108 times 0.425, that's about 23.85 grams of KOH. So we have the mass of the solute. Now, let's calculate the mass of the solution. If we could find the mass of the solute and the solution, we can therefore find the grams of the solvent. So let's use the density of the solution to get the grams of solution. So a 1.13 gram per milliliter solution means that we have 1 milliliter for every 1.13 grams. But let's not start with that. Let's start with the amount of volume that we have, which is 1 liter. So we have 1 liter of solution, and let's convert that into milliliters first. So there are 1,000 milliliters per 1 liter. So the units liters cancel. And now we can convert from milliliters into grams using the density. So a density of 1.13 grams per milliliter means that for every 1 milliliter of solution, there are 1.13 grams of solution. So the units milliliters cancel. So 1,000 times 1.13 is basically 1130 grams of solution. Now we know that the solute plus the solvent equals the solution. So in order to find the grams of solvent, we can use this equation to get the answer. So there's 23.85 grams of solute. We're going to say X is the mass of the solvent, and so the solution is about 1130 grams. So 1130 minus 23.85 will give us the mass of the solvent, and that's 1106.15 grams. That's how many grams of water that we have. So now we could find the molality. So let's make some space. So let's start with the moles. We know we have 0.425 moles of KOH. And if we take that and divide it by the kilograms of solvent, now we have 1106.15 grams of water. So if you convert that 1106.15 grams, if you multiply it by 1 kilogram per 1,000 grams, you can get the kilograms of solvent. 1106 divided by 1,000 is about 1.106 kilograms of water. So moles over kilograms is going to give us the molality. So 0.425 divided by 1.106 is equal to 0.3843 lowercase m. So that is the molality of the solution. That's how you can find it if you're given the molarity of the solution and the density of the solution. Number 5. Calculate the molality of a 28% hydroiodic acid aqueous solution. If it's aqueous, that means it's dissolved in water, so water is a solvent. Now, so we need to find molality given mass percent. A 28% solution means that there's 28 grams of solute, which is HI, for every 100 grams of solution. So since we know that the solute plus the solvent equals the solution, the amount of solvent that we have is the difference between 100 and 28. So that means that we have 72 grams of solvent. So with this information, we can calculate the molality of the solution. So let's start with 28 grams of HI. So let's find the molar mass of HI. The molar mass of HI is about, let's see, for hydrogen it's 1.008, for iodine it's 126.9. So the molar mass is equal to 127 grams of HI for every 1 mole of HI. So now that we have moles, all we need to do is divide by the kilograms of solvent. So we have 72 grams of H2O. And to convert that into kilograms, let's multiply by 1 kilogram per 1,000 grams. So 72 divided by 1,000 is about 0.072 kilograms. So we're going to divide the moles by 0.072 kilograms of solvent. So now we have the molality. So it's just 28 divided by, this should be 127.9, because iodine is 126.9 plus 1. I forgot the 0.9 part. So 28 divided by 127.9, and then take that, which is 0.2189, take that number, divided by 0.072 kilograms. And now you should have the molality, which is 3.04 lowercase m. So that's how you can calculate the molality of the solution if you're given the mass percent. Number 6. Determine the molarity of a 31% HCl aqueous solution having a density of 1.2 grams per milliliter. Let's assume it's aqueous, so water is the solvent. Let's keep it simple. So if we have the mass percent, which is 31%, what that means is that there are 31 grams of HCl out of 100 grams of solution, because 31 out of 100 is 31%, and the difference, 100 minus 31, that's the grams of solvent. So there are 69 grams of H2O. So we have the grams of HCl, which is the solute, and we can convert that into moles. Now to find molarity, we need the moles of solute divided by the liters of solution. So let's focus on the solution part. So out of 100 grams of solution, we know that there are 1 milliliter for every 1.2 grams of solution, based on the density of the solution, which is 1.2 grams per milliliter. So we can cancel the grams of solution, and then we can convert it into liters. 1 liter is equal to 1,000 milliliters. And so those units cross out. So 100 grams divided by 1.2 is going to give us 83.3 milliliters. And if we divide that by 1,000, then the volume of the solution is 0.083 liters. So now we could finish it. Let's take the 31 grams of HCl and let's convert it into moles using the molar mass. So according to the periodic table, the molar mass of hydrogen is about 1.008, and for Cl, chlorine, is 35.45. So combined, the molar mass is 36.458 grams per 1 mole. So now that we have the moles of the solute, we can now divide by the liters of solution, which is 0.083 liters. So 31 divided by 36.458, that's 0.85. Take that, divided by 0.083, and so the molarity is pretty high. It's about 10.2. So that is the molarity of the solution. It's 10.2 moles per liter. By the way, if you want more chemistry practice problems, check out my video on YouTube that's entitled General Chemistry 2 Final Exam Review Study Guide. I also have one on General Chemistry 1 Review Study Guide as well. So you can check that out if you want more practice problems on Gen Chem. So let's work on number 7. Calculate the molarity of a 0.51 molal Ki aqueous solution having a density of 1.3 grams per milliliter. So to find molarity, we need to get the moles of solute and divide it by the liters of solution. So let's break down the word molality. Molality is the moles of solute per kilograms of solvent. So a 0.51 mole solution means that if we have 0.51 moles of Ki, we therefore have 1 kilogram of solvent, which is going to be H2O since it's an aqueous solution, and we know 1 kilogram is about 1,000 grams of water. So we have the moles of solute, which is 0.51, so we don't have to worry about that anymore. What we do need to find is the milliliters of solution, and therefore the liters of solution. So let's start with 0.51 moles of Ki, and let's convert it to grams so we can get the grams of the solute. Potassium has a molar mass of 39.1, and iodine has a molar mass of 126.9. So combined, the molar mass of Ki is 166 grams per 1 mole. So the units moles of Ki cancel. And so 166 times 0.51 is equal to about 84.66 grams of solute. So we know that the solute plus the solvent is equal to the solution. And since we have 84.66 grams of solute and 1,000 grams of solvent, which is water, we therefore have 1,084.66 grams of solution. So now we can use that to find the liters of solution. So let's start with 1,084.66 grams of solution. So keep in mind the density applies to the solution. So there are 1.3 grams of solution for every 1 milliliter. And we know that there's 1 liter for every 1,000 milliliters. So the units grams of solution cancel, and the units milliliters of solution cancel as well. So 1084.66 divided by 1.3, and then take that number divided by 1,000, you should get 0.8, not 4, but 0.8344 liters of solution. So now we can calculate the molarity. We have the moles of solute and the liters of solution, so we need to divide those two numbers. So 0.51 divided by 0.8344 is equal to 0.611 capital M for molarity. So that's the molarity of the solution. There are 0.611 moles of solute per 1 liter of solution. Number 8. Determine the mass percent of a 0.489 molal KCl solution. So the mass percent is the mass of the solute divided by the total mass, which is the mass of the solution, times 100%. So if we have a 0.489 molal solution, that means that there's 0.489 moles of solute, which is KCl, per 1 kilogram of solvent, or 1,000 grams of water, which is 1 kilogram. So we need to find the grams of solute and the grams of solution. We already have the grams of solvent. So let's find the grams of solute. So let's convert 0.489 moles of KCl into grams. So the molar mass of KCl, for K is about 39.1, for Cl it's 35.45, according to the periodic table. And so there are 74.55 grams per 1 mole of KCl. So those units cancel. So 0.489 times 74.55, you should get 36.45 grams of KCl, which is the solute. So we know that the solute plus the solvent equals the solution. So therefore, we can now find the grams of the solution. So 36.45 grams of solute plus 1,000 grams of solvent equals 1,036.45 grams of solution. So now we can calculate the mass percent. So the mass percent of KCl is the mass of the solute, which is 36.45 grams, divided by the mass of the solution, which is 1036.45, and we need to multiply this by 100%. So 36.45 divided by 1036.45 times 100, you should get a mass percent. It's very small, about 3.52. So that's the mass percent of the solution, which is the form of concentration. Number 9. Determine the mass percent of a 1.25 mol HBr solution having a density of 1.27 grams per milliliter. So the molality is 1.25. That means that for every 1.25 moles of HBr, there are 1 kilogram of water, or 1,000 grams of solvent. So let's go ahead and find the mass, or the grams of solute. If we can do that, we can find the grams of the solution, and that's going to allow us to find the mass percent. So the molar mass of HBr, it's 1.008 plus 79.9 based on the periodic table, so that's going to be about 80.908 grams of HBr per 1 mole. So let's multiply these two numbers. So the mass of solute is about 101.135 grams. So if we add the mass of the solute and the solvent, we can get the mass of the solution, which is 1,101.35 grams of solution. So now we can calculate the mass percent. So the mass percent is the mass of the solute, which we know to be 101.135 grams, divided by the mass of the solution, which is 1101.35. And let's multiply that by 100%. So you should get about 9.18% for the mass percent. And that's how you can find it if you're given the molality and the density of the solution. Number 10. Calculate the density of a 0.845 mol sulfuric acid solution that has a molarity of 0.821 m. So go ahead, feel free to pause the video and try this problem yourself, and then unpause it to check the solutions when you're ready. So let's understand what this means. So molality connects moles of solute and kilograms of solvent, and molarity connects moles of solute and liters of solution. In order to find the density, we need the grams of the solution and the liters of solution. The liters of solution we can get from the molarity, but the grams, we need to get it from both. We need to add the grams of solute plus the grams of solvent to get the grams of solution. So let's assume that we have 1 liter of solution. And let's start with molarity. So if we have 1 liter of solution and molarity is 0.821, that means that there are 0.821 moles per 1 liter of solution. So if we have 1 liter of solution, therefore we have 0.821 moles of sulfuric acid. So these units will cancel. And once we have moles of H2SO4, we can convert that into grams. So the molar mass of H2SO4, for hydrogen it's 1.008 times 2, for sulfur it's 32.06, and then plus 16 for oxygen, but you got to multiply that by 4 since there's 4 oxygen atoms. So the molar mass that you should have at this point is about 98.076 grams per 1 mole of H2SO4. So therefore, the grams of H2SO4 equals 0.821 times 98.076. So that's about 80.5 grams of H2SO4. Now, starting with 1 liter of solution, we can multiply this by the molarity, which is 0.821 moles per liter. And once we have the moles of the solute, we can find the kilograms of the solvent by using the molality, which is 1 kilogram of solvent for every 0.845 moles of solute. So moles of solute cancel, and then we can convert this to grams by multiplying it by 1,000. So 1,000 grams per 1 kilogram. So now we can get the grams of water. So 0.821 divided by 0.845 times 1,000 means that there are 971.6 grams of water. Now, we know that these numbers make sense because 971.6 grams is the same as 0.9716 kilograms. And if you multiply the kilograms by the molality, which is 0.845 moles of solute per 1 kilogram, and if you convert that to grams by multiplying it by the molar mass of H2SO4, which is 98.076 grams per 1 mole of H2SO4, you're going to get this answer again. If you type in 0.9716 times 0.845 times 98.076, you're going to get 80.5 grams of sulfuric acid. So we know these numbers agree with one another. So now, let's see if we can finish the problem. Our goal is to find the density. And so if we have a 1 liter solution, that means that there are 1,000 milliliters of solution. And if we add the grams of solute and the grams of solvent, 80.5 plus 971.6 means that there are about 1,052.1 grams of solution. So the density is basically mass divided by volume. So 1,052.1 grams of solution divided by 1,000 milliliters of water will give us a density of 1.052 grams per milliliter. And so that's how you can find the density of the solution if you're given the molality and the molarity of the solution.